time to look at the vertex form of a parabola. So the vertex form of a parabola is actually a really nice form to have because you can directly read off what the vertex is, and then you can look at A to tell you if it's opening up or opening down, and how steep, if it's been stretched vertically or compressed. So here it is, y equals a times the quantity of x minus h squared plus k, where h and k are the vertex. And I believe this is the form that we were working with early on in the first unit that we did. So if we look at this, we can read off the vertex very easily. The vertex is going to be 2, 3, and if we need to graph it, so let's go ahead, I'll take the blue pen, going over 2, 1, 2, and up 1, 2, 3. Put a point there. Ooh, can't really see that. Let's put a bigger point. That's a big dot. Okay, but I will use the little pen to help graph it. Okay, so if you guys remember the pattern that I had talked about in class earlier, the 1, 1, 2, 4, since A is 1, it's going to be our standard pattern. So going from the vertex, and I'll go back to my big dot here, from our vertex, we're going to count over 1 unit and up 1, really big dot, okay, and then go back to the vertex and we're going to go over 2 units and up 1, 2, 3, 4, okay, and then remember that the axis of symmetry goes through the vertex, so it's going to be symmetric, so we're going to get to this point and then that point right there. So you get those 5 points, and you know what, I'm actually not going to attempt to draw that because we've all seen how bad that comes out, but you could connect the dots and get your curve of the parabola. Now, we couldn't do what we did before because this number right here is not C. It's not the y-intercept. Remember, that is the y-coordinate of our vertex. So it looks like the y-intercept is 1, 2, 3, 4, 5, 6, 7. It turns out to be 7, which you don't see that initially in this form. So we couldn't do what we had done before in order to graph it. So don't forget that pattern that I had taught to you about earlier. Okay, so let's try it again. Another problem. All right, so here we have an equation. It's in standard form. They're asking us to convert it into vertex form before we graph. And I know you're looking at that and you say, oh, I can do the negative b over 2a thing and figure out the vertex, and there's the y-intercept right there. Why do I even have to bother? Well, because sometimes it is going to be easier to have it in the vertex form as opposed to the other form. Maybe this number, the y-intercept, is really large, or it's a fraction or something. Okay, so let's go through the steps of converting it to the vertex form. Since the vertex form has a binomial quantity squared, what we're going to do is try to convert this into that form that has a perfect square trinomial, which means we're going to complete the square. This was why we spent a day practicing completing the square. It's a little different, however, because instead of this equaling 0, we're going to keep the y there. We need that in order for this to be a function. So we're going to have this y. I'm going to leave a space in between the 6x and the 5 because I'm going to add something here, right, to complete the square. I'm completing the square on x squared plus 6x. So half of 6 is 3, 3 squared is 9, and I add 9. But remember, I have to keep my equation balanced. So if I add 9 over here, I would have to add 9 to this side. But I also want y to be by itself. So if I added 9 over here, that means I'd have to subtract it to move it over there. So why don't I just subtract it right away? So if you look, what I have in red, I've really just added 0, which doesn't change the value. It's going to change the look of it, though. Okay, so what I'm going to do is for these 3, this is my perfect square trinomial. I factor that as x plus 3 quantity squared, and then I add the 5 and the negative 9 to get negative 4, and then there is my vertex at negative 3, negative 4, 2, 3, 4, and using my pattern over 1, up 1, over 2, up 1, 2, 3, 4, or at this point, put that there and that there. From here, we know that the y-intercept is 5, so count up 1, 2, 3, 4, 5. We could have done that, and then it looks like it's 1, 2, 3 over, so 1, 2, 3 over. But I want you guys to see something here. Once again, I'm not going to connect the dots. Okay, so we had the 1, 1, 2, 4. The next number in that pattern is 3. What's 3 squared? 9. So let's see, if you count up 1, 2, 3, 4, 5, 6, 7, 8, 9. So it still follows that same pattern. We're all getting the right things, so there you go. Okay, one more example that we're going to do, because it does get a little bit more complicated. Okay, here we go. So now we have a quadratic in standard form, but a is not 1. In order to complete the square, a has to be 1. Okay, so how do we deal with that? So you might be thinking of, when we did completing the square before, we divided through by a the entire equation, right? Well, we don't want to do that. We want to keep a here. We just want it to be factored out in front of our quantity that's being squared. So what I'm going to do is I'm going to only look at these two terms that have x, the quadratic and linear term, and I'm going to factor out this -2. So it's going to end up looking like this. And remember, 8 divided by -2, that turns into a -4. And then I'm going to complete the square just on this quantity right here. So half of 4 is 2, 2 squared is 4, so I'm going to add 4 inside the parentheses. Now this is the tricky part. I didn't really add 4 here. I added more than 4. In fact, it's weird because this is a -2. So -2, if I were to distribute that through, I actually added a -8. So if I added a -8 here, I'd have to add a -8 there, which means I'm subtracting 8 on the left side, which means to move it over here, I'd have to add 8. Did I just confuse you? Just remember, this is a +4 times -2 is a -8. So I put a -8 here when I put that 4. So -8, the opposite of -8 is +8, and that's what has to go over here. Just remember, you want to keep it balanced. You technically want to have only added 0 to this side. Okay, so this we're going to factor, put it in our vertex form. We can read off the vertex as 2, 3. So let's see, over 2, and 2, up 1, 2, 3. Now our pattern, first of all, since this is a negative, our parabola is going to open down. And the pattern, since this is a 2, it's not 1, 1, 2, 4 anymore, it's 1, 2, 2, 8. So we take that, the y values of our pattern and multiply it by 2. So that means from here I'm going to go over 1 and down 2. And then I'll go back here, I'm going to go over 2 and down 8, not 4. So 1, 2, 3, 4, 6, 7, 8. And then I should mirror that. If I did this right, this looks like this is the y-intercept. Y-intercept should be -5. 1, 2, 3, 4, 5. Yep, did it right. Okay, and then you can connect the dots and make your parabola. Okay, now some of you might be thinking, wait a minute, why did I have to go through all of that work of completing the square where this is all very confusing when I can calculate the vertex using my -b over 2a and c minus b squared over 4a? And in fact, you can. Take a look at this. Okay, so h is the x-coordinate of your vertex, so -b over 2a is 2. There it is. Y, which is k, right, the y value of your vertex, c minus b squared over 4a, work that out. Look, there's k, it's 3. You can take this number and that number, plug it in for h and k, but just remember this number right here, the -2, that's a, and that has to get carried down below here to get multiplied to that quantity. So if you don't feel like completing the square, if I don't specifically ask you to complete the square and I don't want to see those steps, go ahead and do it this way instead if you like. Okay? Not too bad. All right, now, little different thing now. Last problem. It says find the equation of the parabola given the vertex is -2, 5, and it passes through the point 1, -3. And we're going to leave it in vertex form. So kind of like we did before when we built our quadratic equations, if I gave you the x-intercepts and one other point, we're going to do the same thing. We're going to plug in the h and k into our vertex form, leaving the variable of a. And then with this point, I'm going to plug in the y and the x in here for y and x. Plug it in, calculate all this out, and solve for a. So I'm going to subtract 5. This becomes negative 8. Add this becomes 3 squared, which is 9. Divide by 9, I get negative 8 over 9 for a. And now the last part is just to take this fraction and replace a up here, and you get your equation in vertex form. So that should be pretty easy. Okay, so I hope you guys end up liking the vertex form as much as I do. So long.